more than 1,000 identified compounds, which all comprise carbon atoms, but also can include other functional groups like hydroxyl groups, and I just listed some examples like propane, benzene, alpha-penene, and methanol is one example of a hydroxyl group, and they can be emitted by natural sources, so-called VOCs, and anthropogenic sources. And there are, of course, topics of interest. The most famous one is the ozone formation. I guess everybody knows about that, where VOC and NOx together have a huge impact on the ozone formation. And the other one I like to point out is the formation of secondary organic aerosols. This is a topic which is getting more and more interesting. There, VOC is not the is a precursor to produce this secondary organic aerosol formation. When we do the sampling, we use canisters, and we sample the VOCs ground-based and an airborne measurement. We use 2-liter stainless steel canisters, and after we are bringing these samples back to the laboratory and analyze them with a gas chromatograph or a mass spectrometer, and then with a flame ionization detector. But these canisters have to fill some objectives, and the very first one is the cleaning lid. So we have to remove all residues from previous samples, especially the VOCs. Then the canister surface has to be inert, and we have to wetten the canister surfaces if we want to sample in low humidity areas. Otherwise, we're going to have a bad impact on sample results afterwards. Unfortunately, cleaning isn't that easy. As I remember, I had these examples, propane, benzene, and alpha-penene, and this arrow already shows getting harder to remove them because the structure of the molecule and the characteristics have a huge impact on the removability. So I also wrote down the vapor pressure. As you notice, propane has a much higher vapor pressure than alpha-penene, which means it's more volatile. So this one